through 40 here, 31 through 40. Starting with question 31. It's asking which composition of transformations maps A, D, D, E, F into quadrant 1. So here we go. So if you think about quadrant 1, where is quadrant 1? Remember, it's always, this is 1, 2, 3, and 4, right? So we want to have it go somewhere in this quadrant here, okay? So what we want to do is, the only way we can really go about doing it is going through each scenario and seeing which one it does. It does, okay? So what I would do is I would only take 1 point, okay? And let's just choose D for now, and then we'll go from there and see which one or where it lies in the quadrant, so that we don't have to do it complicated and make it as dirty and whatever for this whole thing. So our first thing is that we want to do reflection in the scenario of where y equals x. Now remember that that is a reflection that goes like this. So it ends up going reflecting down here. So if that's the case, the rule for this is x comma y is going to go where x changes to negative and y changes to its opposite sign. Okay, so like I said, let's concentrate on point D, and then we'll go through each scenario until we find the right answer. So D has coordinates of 1, 2, so it's -2 and +2. So all we have to do now is that we're just going to take that point D and we're going to change it to its opposite. So here's our reflection of 2, -2. So let's go ahead and put that point in that spot. So here we go. 1, 2, and then down 2. So that's our D prime. So we're not quite in there. So what would we need to do in order to be able to get it into the quadrant here? And it says that we're doing a translation of, and I'm going to keep this all in purple, a translation of going 1 to the left and then up 6. Okay, 1 to the left, so 1 to the left and then up 6. 1, 2, 3, 4, 5, 6. That would be my D double prime. Okay, so it lands in quadrant 1, but I'm going to sit there and double check it. So by doing the same thing with this thing, we have our point, which we already have, which is -2, 2, and we're going to subtract 1 from it, so that would give us a -3, and then a -6, which would give us a -4. So here we go. So we'll go 1, 2, 3, 4, 1, 2, 3, 4. Down here, that would hit there, and then it says to do what? Reflect it again across this. So it would be going here, it would go here, and that would still stay in the third quadrant. So we know that B is not the answer. Okay, clockwise rotation of the origin about 180 degrees. So let's do this one in a different color. Let's go blue. Again, when we do that, we just change it to its opposites again when we do that. So again, we're going to use this point of our rotation 180, which is going to be 2, -2. And then it says to do it reflected across the y-axis, which is the vertical one, and we reflect it over here, and it would end up being here, so that would be there. So we know that that doesn't work. Counterclockwise rotation about the origin of 90 degrees, and then transforming or translating it the same way we did up here. So again, counterclockwise. So that means we're going this way. And remember, the rule for that was, and I'm going to look at my paper again because I can't remember it very well off of my top of my head, is -y, x. So again, we're going to take this point, we're going to switch them. So 2, and we're going to change it to negative because it's positive, and we're going to keep that one the same. So we're going to go -2, -2, and there's that point right there. Okay, and then it says we need to move it 1 to the left and up 6, and it ends up being in quadrant 1 again. So it looks like A would be our answer for question number 31. Okay, all right. Okay, question number 32. Which of the following transformations maps FGH onto F prime, G prime, H prime here? So this gives us a little bit of a harder one to do because we got to figure it all out. So we have some scenarios here. We have a rotation of a counterclockwise and then reflected Okay, this one is rotated 90 degrees, and then it's translated. Okay, and then this one triangle across the x-axis and then reflected, so reflected across the x-axis and then reflected across the y-axis, and then this triangle moves up, so translated 5 units up and then across the y-axis here. So we need to kind of look at this whole thing here. Notice that our original one, which is down here, and the F and H lie on the origin. So that kind of gives it away. That's a subtle hint here to look at. And then look at H is down here, and then H is over here. So it looks like there's probably some kind of a rotation going. And it's here. And then the other part it shows is that this being on the origin, and then the H and F are not on any of the axes here. So that means it's probably doing some kind of a translation here. So we're talking about a rotation. Now, a rotation, if we're talking about rotation, these are some subtle hints and thoughts to think about. Rotate. If I rotate this 180 degrees, that means that that thing would be completely turned and upside down, where the F would be down here and the H would be up here, so we would twist it. So we know that it's not going to be rotating 180 degrees. So we can probably eliminate question A here. But sometimes, when you do some reflections in C and D, that makes a huge difference there too. But we know there has to be, these are all being translated, but these are being reflected. So I'm going to sit there and look at question B and see if it actually works. Okay, so what I'm going to do is I'm just going to take one point, and I'm not going to take the point that's on the axis. I'm going to take point G, and let's write those coordinates down there. So we're going to go -2, and we're going to go down 1, 2, 3, 4, -4. So that's G. So now we're going to follow this rule here. So our clockwise rotation. Now remember, our clockwise rotation is the same thing as our 270 degree counter clockwise. Okay, so that means the rule that applies for that is going to be y comma -x. Okay, so I'm going to change that into a different color. So here's our original G. We're going to switch spots. Okay, so we're going to go 4 and 2, but the y stays the same. So y is negative, so that's going to stay the same. But the x is negative, and we're changing it to its opposite. So that's our number here. So we're going to go -4, 2. This is for our G. Remember that, right? 1, 2, 3, 4, and then up to 1, 2. Okay, and now that's our new G, and then it tells us that we need to translate it 3 units up. Okay, and that means in 1 unit to the right. So up 3 units, 1, 2, 3, and then to the left 1. And that would be our G there. Okay, so that one didn't quite work as we thought it would. Okay. Oh, see, I did something wrong here where we're talking about. So we're rotating it around point F. Okay. So when we rotate around point F, that means we need to move F to the origin. Okay, so that means we're moving it over 1 to the, so we're going to move it. So it's our vertex. So that's where I screwed up. So we're going to go 1 to the left, and then 1 down. Okay, so that means we need to do the same thing to our, whoops, I'm sorry. We're moving it up 2 units. So that means we're going to go 0, and we're going to go 2. So that means I need to do the same thing to the G before I even did any of this stuff. So let's do that first. I apologize, I didn't make that point here. So let's take our G, and we're going to move it up 2 units. So 2 units would be -2, comma -2 now. Okay, that would be here, so that we would -2. So there's that. Then we can now rotate it. Okay, so with our rule that we applied. Okay, so we're going to switch our x and our y. X goes to its opposite. So it's going to be a +2. Okay, and the y is going to stay the same, which is a -2. So now we're going to go -2. And then we're going to go up 2, 1, 2, right? Okay. And that would be a rotation there. for that. And remember, this looks like it's not fitting too well, but we got this as our rotation number, and now we need to go 3 units up and 1 to the right. So that means we're going to go 1 to the right, which is right here, okay? And then we're going to go up 3 units, right? 1, 2, 3, okay? And that doesn't match with what we do, but remember what we forgot to do is, remember we got to do our opposite of what our vector was, so that means we're going to have to go back down to 1, 2, and look at what hits right there. That was kind of a complicated one, but we had to kind of work backwards, and our answer is going to be B. Whew. Okay, I promise these get a little bit easier as we go along here, especially these next ones. All right, question number 33 has to do with the exterior angle theorem that we talked about here. It says that angle 1 and angle 2 add up to be angle 4. So we're going to put marks in here, and that's going to equal that thing out there. So we add those up. So which statement would be a part of her proof to prove that this angle 4 does add up to be those? Now remember, a triangle has how many degrees in it? 180. If we know 2 of them, we would subtract whatever these 2 added up to get the third one. Then we would have, again, hint, hint here, we have a straight line which equals 180 degrees. So that means we would take angle 3 and angle 4 and we would add them up, and guess what they'd add up to be? 180 degrees. So this one would be the one that we would use in that part of the proof. All right, that one's a quick and easy one compared to the last one. All right, scenario and question number 34. We're looking for to answer or fill in the blank of this one here, and it's based on the rule of substitution, okay? So we have our previous one that we look at where we know the measurement of PCB, which is the matching of the one above it, now equals plus angle 5 equals 180 degrees, and then angle 4 and angle 2 add up to be PCB. So we're talking about substitution. So what we're basically going to do is we're going to take something from here, and we're probably going to substitute it into here, okay? So what do you think we need to put in there for that scenario? So we're going to take, or vice versa, or we're going to take this thing, which I would sit there and say, and I would probably replace it with this one. So I would sit there and say, okay, angle 4 plus angle 2 plus, now I've got angle 5 plus equals 180 degrees. So we replace this with this, so then is that down there? It is, and it's in C down there. I apologize, I didn't show the whole thing on that one. All right, one more to go in this section before we call it quits on this one. I know that this one does not have a multiple choice, but the rules apply. Did a multiple choice version of it for you. Okay, so we got about a minute and a half to work on this one. Again, based on the rule that we just talked about. Remember, triangles equal 180 degrees. That means we can find the measurement of that angle right there by just adding up 33 and 47. So 33 plus 47 equals 80 degrees. If this equals 80 degrees, that means this angle over here equals 100 degrees. That means that this angle also equals 100 degrees, and this one equals 80 degrees because of what? Vertical angles. Okay? That means we can take these two numbers and we can add them up, and that would give us, or did I do it backwards again on this one? 180 degrees, 33. Yeah, this should be, I got it backwards. I got a little hurry. This one's actually equal to 100. This one's 80. This one's 80. And so this one's 100. So we have 148. So guess what? We add those up. This equals 148 degrees. And we got our answer there, and that would what our answer would be. Or we could take 80 degrees, 100 degrees and 48 degrees and subtract it. And this would give us, so 180 minus 148 equals 32 degrees. And then we can sit there and know there's 180. We take 32 from 180, and that gives us our answer of 148 degrees. All right, we'll see you in a few.